Hi, I'm John. Welcome to the next video in our Haas certification series. In this video, we're going to learn some basics about mill cutting tools. Here are the things that we'll cover. We'll introduce you to a few common cutting tools for drilling holes, milling different shapes, and making screw threads. We'll also look at how designs of these tools differ based on the material they're designed to cut. So let's dive right in. Arguably, the most common cutting tool used in manufacturing is a drill bit. Now, I assume everyone knows that a drill bit has two cutting edges and rotates on its center axis. As it's fed into the material, the rotating motion provides continuous cutting action. The material that's cut, referred to as chips, are forced up these flutes and out of the hole. It's a relatively simple process that works very well. Drill bits come in a massive number of different sizes, so precision holes can be drilled to almost any specification. They're also made from many different materials and often have special surface coating to extend their life and lower the per hole cost when they're used in a production environment. Once drills get to a certain size, it becomes more economical to use drills with indexable inserts like these. This way, when the drill's cutting edges get dull, you just replace the insert. This example has two inserts. Now let's look at milling cutters. The most common is called an end mill. An end mill rotates on its center axis like a drill, but it's primarily designed to cut it with the side of the tool so that the cut surface is parallel to the axis of rotation. Some versions of this tool can cut vertically like a drill, but they're not as efficient in doing so. End mills come in different configurations. They can be square end with sharp corners or have radii on the corners like this one. They can even have a 45-degree chamfer on those sharp edges to keep them from chipping when cutting tougher materials. Now, that's not to be confused with a chamfer mill, which also have an angle, usually 45 degrees, but on the whole end and not just on the corners. These cutters are used to produce chamfers to break sharp edges on corners after milling. End mills with corner radii are often called bullnose end mills. They also make them with spherical ends called ball-nose end mills. The spherical ends allow them to be used to cut all kinds of curved shapes. You can even get end mills made with tapered sides for special applications. As with drills, once you get above a certain size, it becomes more economical to use an end mill body with replaceable inserts like this. Now here's a different type of milling cutter where the surface to be cut is perpendicular to the tool's axis of rotation. This is called a face mill because its primary function is to cut the face of a part. They come in different configurations, but the most common is a 45-degree angle on the outside. Now, the best way to tell the difference between an insert end mill and any other type of insert cutter is to look at the side of the insert. If this is 90 degrees to the bottom, it's an end mill. If it's not 90 degrees, it's not an end mill. Now, this cutter is called a slot mill. This particular one has a specific form on it for making the slot in the side of a part. Some of these milling cutters are designed only for roughing material and are not designed to give a beautiful surface finish. For example, this is a roughing end mill. Some refer to this as a corncob mill because of the shape. There are two primary reasons to use an end mill like this for roughing. The first is that the corncob shape lowers the horsepower required to make the cut because the entire surface from here to here is not engaged in the cut. The corncobs are staggered, so the next flute cuts material that this flute missed. Anytime you see slots or grooves in the cutting edges of a cutter, it's because that cutter is designed primarily for roughing. So, if we have roughing end mills, are there end mills designed solely for finishing? Silly question, of course there are. Usually end mills with more than 5 flutes, or cutting edges, are designed for finishing. The more flutes there are on a milling cutter, the smaller the gap between them. These gaps, known as gullets, are where the chips go when they're cut. Smaller gullets mean less room for the chips, so you cannot take an aggressive rough cut that creates big chips because there's nowhere for the chips to go. These multi-flute end mills are very good at finishing hardened steels where cutting large chips isn't usually done anyway, since the material is so difficult to cut. The last in our group of common mill cutters are ones designed for cutting screw threads. There are two basic types, taps and thread mill cutters. Taps are relatively simple. They're meant to cut screw threads on the inside of drilled holes. Each different size tap has a specific hole diameter that needs to be drilled before the tap cuts threads on the inside of the hole. The tap has a specific thread form on it and needs to be fed into the hole at a specific feed rate synchronized to the rotational speed of the spindle. The machine has a rigid tapping cycle that synchronizes the spindle speed and the feed rate on the way into the hole and remains synchronized as the rotation stops and reverses to back out of the hole. Here's a tip about cutting taps. If the flutes spiral around the tap like a twist drill, the chips cut by the tap will come out of the top of the hole. You should use this type of tap when the hole you're tapping does not go all the way through the material. These are called blind holes. Taps with straight flutes push chips down into the hole. These work great when the hole goes all the way through the material so the chips can come out at the bottom of the hole. If the hole does not go through, you must drill really deep. If you don't leave enough extra room for the chips, you'll break the tap every time. Here's the general rule of thumb. Use straight flute taps on through holes and spiral flute taps on blind holes. Now, a thread mill cutter can be a single point thread mill, or it can have multiple thread forms on it, like this one. Typically, thread mills like these are used to cut screw threads on the outside of a workpiece or on the inside diameter of a larger hole. With thread mills, we program a circular motion with a helical move that is equal to the pitch of the thread. The pitch of the thread is the distance between each thread form. It's also the distance a screw travels in one full rotation. Now let's talk about the differences when the same type of cutter is designed to cut different materials. If you remember, in the chapter just before this one, we looked at 4 common workpiece materials: mild steel, aluminum, harder alloy steel, and stainless steels. For the most part, the 3 types of steel cut similarly, whereas the real big difference comes when we start talking about aluminum. So, end mills designed for aluminum have either 2 or 3 flutes. These end mills work well on aluminum because they have very large gullets with lots of room for aggressive cutting of chips. In a pinch, you could also cut mild steel reasonably well with these end mills. Whereas end mills with 4 or more flutes are specifically designed to cut steel. These end mills are spectacularly bad at cutting aluminum. When it comes to end mills, you can basically use the same end mill to cut mild steel, alloy steel, and stainless steel. It all comes down to the correct spindle speed and feed rate for the given material. Cutting tool manufacturers also offer different coatings to enhance longevity on harder alloy steel and tougher stainless steels. Most drill geometries will work acceptably on all materials, aluminum and the steels. Sure, there are high-performance drills specifically designed for each of these materials, but they're best utilized in high-production, high-volume applications. So, that's a high-level overview of cutting tools. Let's recap what we learned. Twist drills cut holes and insert drills cut big holes. We learned that end mills cut parallel to the rotating axis while face mills cut perpendicular to the rotating axis. We learned that end mills can have radii or chamfers on the corners and can have a spherical shape on the end. We learned about slot mills and that almost any type of milling cutter can be made with replaceable inserts. We learned about taps and thread mills for cutting threads, and finally, we learned that there are different cutter geometries for aluminum and softer materials versus steel. Thanks for watching, and we'll see you in the next lesson.